In this episode, I'm going to look at a couple of old radios that I picked up on Facebook for $10 each. These are going back to the 1940s, early 50s, just AM shortwave radios, vacuum tube, of course. Two different designs, one's a Phillips and the other's an RCA. Let's check it out. Check out what I just picked up. $10 each. Guy that bought this one, he paid $65.99 for this one at an antique shop, and it doesn't work. So he cut his losses and sold it for $10. There's a little Bakelite Phillips. I think this is a Phillips. It's got shortwave on it at AM. This one here is a, what is this one? Is this an RCA? AM and shortwave. Wooden chassis. This would be early 1940s, I'm guessing. 40, 41 maybe. Let's just see what it is. This one's got a transformer in it. This is an RCA made in Canada. It's an M45A with built-in antenna. And we're going to do a restoration. Or a restoration in my eyes, which means replacing the electronic components that need to be replaced. I'm not going to be touching the cabinet on this one, at least not yet, although this one's in pretty good shape. This will actually probably buff up quite nice because there's no deep gouges on it. There's a couple scratches. But anyway, this is this one. Power cord is all stuffed in here. Looks like all the tubes are in place. There's 5 tubes here, it looks like. 1, 2, 3, 4, 5. Yeah, 5 tubes. And this one looks to be, is this an electrodynamic speaker? This is an electrodynamic speaker. There's something stuffed around the speaker here. Paper. Okay, anyway. We're going to work on this one first. So this will be another project for another video. I just wanted to show you guys this one. Give you a little teaser. Could have worked on either one first, but I think I'm going to work on this one in this episode. And then we'll deal with this one next. So this one's Phillips. Covers 5.5 to 16 megacycles or megahertz on the shortwave band, and 550 or 530 kilocycles to 1700 kilocycles on the AM band. There'll be a switch over here, I guess, to switch. Probably one of these is to switch shortwave. Yeah, here we go. Okay, so shortwave and broadcast, tuning dial, volume, and this is probably, I think this one's got, if I look on the back, this one has, it has an auxiliary input, yeah, switch here, phono and radio. So it's got a phono input on it as well. And the other one's probably a tone control. This is probably a low, mid, and high tone control on this side, I would think. Anyway, the guy that sold me this radio told me that it worked, but it faded out after it ran for a few minutes. So it sounds like capacitor issue. The other one, apparently, I don't know. The guy, I don't know the sort of the other one. They both need service, but I figured I would start with this one because it's small and it's kind of unique. I don't think I've ever seen a Phillips radio, but this was also made in Canada. You see, it's patented 1935 to 1953, but this is a Bakelite, so this would be probably closer to 1953, 54, somewhere there. It's going to be in the 50s. That's a standard AA5 sub-miniature tubes, kind of like the Rogers radio that I already have, but it doesn't have shortwave. So let's pop this one apart, and we will get into the unit and start changing the capacitors that need to be replaced before powering it up. Because the last thing I want to do is power up a radio that is full of bad caps that are going to be leaking if it's full of paper caps. And this should be of the era of the paper capacitor. We know someone's been into this unit before because it's got 3 different types of screws in it. It's got a 1/4 inch, a slot, and a Robertson. So this radio has been serviced in the past. That's always a telltale sign when you've got 3 different types of screws in it. That it was at a shop, I'm sure, at some point, and the shops of the day generally tended to lose screws and just replace them with whatever they could find. At least every shop that I ever worked at did that. We'll disconnect the antenna. And I have worked at a few, 3 to be exact. I worked for Sony, was one place that I worked. And then I worked at a small shop when I was in high school that is long gone. And then I worked at another shop after Sony that I was there 20 years, which has also been gone now for about 10 years. Like the antenna. That's the antenna. Look, see? Wire is just connected to this silver foil. That acts as the antenna on it. Alright, here's our 5 tubes. Easy to get at. They've been changed too. That's an RCA tube. Got a big Mallory cap inside here. This will be our 35W4. It's a rectifier. Probably 50C5. That's going to be the audio amplifier. This one's got an external input. It says phono. I don't know if it's magnetic or whether it's ceramic. Probably ceramic. This was union made. So let's pull the knobs off and take the chassis out. These should pop off. This looks like this glass lifts out on here too. Oh, look at that. I don't think that's supposed to come out. I think the glue has dried up on here. But I do need to get the shafts off on here, otherwise this thing's not going to come apart very easily. Actually, let's remove this screw here. This bottom plate may come off without having to actually remove the chassis. And that will save me a lot of work. I was just looking at this and realized that there's 2 screws missing from here. And voila, we don't have to even take the radio apart anymore. I'm liking this more and more as it is. I can put the knobs back on as they don't need to come off any more than they are. So as you can see, these switches here operate. Switch here, and this one operates. Another switch up here. This is the tone control. So we've got some paper capacitors in here that need to be replaced. There's a bunch of them. 6, 7, 8, 9, 10. I guess about 11 to be exact. These red caps, these are actually paper capacitors themselves. They just have an epoxy coating on them, but they're still the same crap inside. So we need to change, as you can see, we need to change all these ones out. And the reason that we need to change them is they are what block the DC voltage from one stage getting into the next one. So let's start changing these caps. I got to see what I've got. Hopefully I've got all the ones that I need, and then I can go ahead and do this. If not, I'll have to get some more on my day off. Okay, I've determined that I don't have all the caps I need for this one in stock. I'm going to have to get them. So this video is just going to be kind of a teaser for you guys. I'll get the other one and we'll pull the other radio apart. I'm going to take inventory as to what I need for this, what sizes I need, and then I will bring them in and we'll do both of these radios during the week. Since I don't want to plug it in right now just because I don't want to put any undue stress on the tubes. I guess I probably could bring it up on my dim bulb and just see what it does, and keep the current limited and only operate it for a couple of minutes, and it should be okay without doing any serious damage. But I certainly wouldn't want to run it for any length of time because leaky capacitor is going to overdrive a tube, and that's not what you want to do for these old tubes. So maybe we will bring this up just on the dim bulb, just so I can see what it does, and then we'll get all the parts for it. I've got it tuned to the broadcast band, approximately where my test transmitter is. I'll turn on the power and see if we draw any power whatsoever, and see if any of the tubes are even going to start to light up. Because hey, we may have open tubes in this thing. I don't see any current whatsoever coming out of my dim bulb tester. I see nothing lighting up, so we may even have open filaments on tubes on this thing before I even get going. I may have to start looking for an open tube. I've got a set of tubes for one of these to begin with, but I see nothing at all. Like it's not even plugged in. Looks like somebody has sprayed this switch. I wonder if the switch is any good. Just see if I'm getting any voltage across the switch. It's off now, so I should see voltage across the switch in AC mode. If the filaments have got continuity, I should see 120 volts across the switch, which I do. So we have continuity somewhere. How do I ever turn it on? I still see 120 volts across the switch. I think that switch is shot. See, I'm looking at this. It looks like somebody sprayed a bunch of stuff in here. And also when I turn it on, it almost sounds like sizzling in the switch. So let's throw a jumper across the switch. I just killed the power. That's why the light went out. My light is plugged into the switch to power. Okay, this will bypass this AC switch. It looks like somebody's been soldering on this tube. I just want to see if the tubes light up. So we're still on the dim bulb tester. Now the switch is bypassed. Is anything going to start to light up? I still don't see any current registering on my dim bulb tester. Or if there is, there's not much being drawn. I don't see the tubes lighting up at all. Even though I do have a big box full of vintage tubes, as you can see, these are octal tubes, not miniature tubes. And I don't have a backup set of miniature tubes other than in a radio, which I have, which I can certainly use those to sub in and see which tube is bad, or we can just measure it. I'm pretty sure it's probably the 35W4. That's usually the tube that fails when they go. That's usually the one that the filament goes open on, is the rectifier tube. But I don't, as I say, don't have one offhand sitting with me right now to sub. But what we'll do is we will measure the filaments and see which filament is open. Figure out which tube it needs for starters. I tell you though, I'm batting 0 for 2 right now from this Facebook seller, because it's the same fellow that I bought that Sony reel-to-reel video recorder from a month or so ago. The heads were ripped right out of it. This is the second piece I bought from that guy that's had major problems and parts blown up besides the normal maintenance stuff. So I'm having second thoughts about maybe buying anything in the future from this fella. But bad luck maybe, but anyway. We'll remove the jumper, because even though that switch does have a problem, as we can see when the switch is turned on, maybe it's going to conduct now, but I had 120 volts across it before when it was in the on position. Now it's working. Nope, it's not, you see. The switch is on. Oh, there it goes. But I did have 120 volts across it, so the switch itself has a problem too. As you can see, I got 120 volts, the switch is on. It should be 0, because the switch should be shorting. So that switch is bad as well. As I say, it looks like somebody sprayed something on it. Look, it's It's all oily and wet. Like somebody sprayed cleaner into that switch and into that control. But it's still not lighting up, so let's check the tubes and see which one's open. We'll start out with the rectifier tube, as this is the most likely culprit. Got to figure out which ones are the filaments on here. There's actually 2 filaments on these that are in series with each other. And that one's good. Well, that one's good too. So that tube is not opened. Right? Get filaments. Filaments are good on that one. The reason why they have 2 filaments in series is there's a 6-volt drop across one that the dial light is placed in parallel across one of the 2 filaments in the Rogers W4. And the filaments are, gotta see which leads are which. We go down to the filaments. It looks like these 2 pins here are the filaments. So do we have continuity? Yes, we do. We have continuity. I should make sure that the right tubes are plugged into the right tube sockets too. That would be the first thing probably to check. 12BE6, yep. 12BA6, yep. And that one should be 12AT. That's the audio preamp over here. Could be the audio output too. It could be the 50C5 that's open. Usually it's the tubes that are the higher voltage tubes are usually the ones that go open. It looks like, which are my tubes on this one? Which are the pins? Could be these 2. Yep. Yeah, that one's okay. Continuity wise for the filament. Get my buddy to bring over his tube tester. And no, I don't have a tube tester. And that's because every time I've gone to a ham flea market looking for tube testers, this is the preamp, people are asking ridiculous prices. Another Rogers tube. I've seen some tube testers that shouldn't be worth more than about $20, people asking $400 or $500 for it, and that's not going to happen. If I can get a tube tester for $20, I'll buy one, but I'm not paying no $400 or $500 for one. Just looking to see. I'll just borrow my buddies every time I need to test tubes. Don't need them that often. I do have a CRT tester, but that kind of doesn't help me for this. It could be these 2 here. Yeah, that one's measuring. That one's measuring continuity, so that leaves just this last one. And if it's not that, then there's a connection somewhere else that's preventing the. It's these 2 here. Ah, yeah. So 50C5. That would make sense too, because if there was a capacitor that was bad and this tube was played, this is the one that would have really heated up. So, and this one drops 50 volts across the filament. So it looks like the filament is open on this one here, is what it looks like. Maybe just test it. And that makes sense, because the guy I bought it from said he had it playing and it faded out. Yeah, he overloaded the tube and popped the filament. Here. Then it cooled down and faded out. Yeah, that one's open. See, meter. So the 50C5 is the one that's gone open. More than likely what made this tube fail was a bad coupling capacitor from the plate of the preamp tube that provided a strong DC positive bias on the grid, which would have red plated this tube in no time, drew a lot of current, made the tube really overheat. This is a Marconi tube, but we'll find one. I've got one in another radio. We'll get the capacitors for this. I'll do an inventory. We'll get the caps for this. We'll change them out, and then I will find a tube for it and make it work. Okay, let's get the other radio and do an inventory on it. Okay, now I'll move on to this other $10 non-functioning radio. Like the other one, we'll pull the chassis and see what we need for this one. This one's a little bit older than the other. It's actually a whole lot older. This one uses a 6K6G, a 6SQ7, a 5Y4G, 6SK7, and a 6SA7. This one uses a transformer, of course, so it's not an AA5. Still a 5-tube radio, but they're all 6-volt filaments on this one. We'll pull the knobs off, pull the chassis. Oh, that doesn't. I like the look of that. That knob doesn't want to come off. It's actually pulling the whole shaft out with it. I think that's the. Is that the tuning dial? That's the tuning one. That one is kind of stuck. Well, let's see if we can. Let's see if we can unstick it. I don't want to pull this because I don't want to pull the shaft right out of the chassis. And if we look down here, the shaft is actually separating from the chassis. So I'm just going to hold the knob, or hold the shaft in place and see if I can pull the knob off without. There we go. Because the last thing I want to happen is to have that knob pull through and take the tuning string away with it. Okay, we'll pull the screws out that hold the chassis in place and do an inventory for parts on this one. And then I'll get all the parts, and well, I might even have the ones I need for this. We'll see. I didn't have all the ones I needed for the other one, but it's beside the point. The tubes are shot. Whenever you get into these old units like this, you never know what's going to jump out at you as far as problems. You hope that you're going to get one that someone hasn't tried to run, but the problem with a lot of this antique stuff is that people don't know, and they pick them up. They get them at garage sales or antique shops or whatever. They don't know anything about them, and the first thing they do is they try to run them and think, oh, this is going to be neat. Let's run this old tube radio. I want to see how it sounds, and they don't take any precautions or do any servicing that's required, and then they wonder why they break. This one here, the speaker grill is coming apart on. It's okay, we can reattach that later. Take the chassis out. What the heck? That's the antenna. Yeah, that's part of an antenna. Look at the grill. Someone's fixed that up at one point. So you used a piece from a cardboard box with copper staples to staple on a new grill. It's kind of a botched up repair. Again, you never know what you're getting into. Asbestos, for sure, in the bottom there, so be careful not to disturb any of that. Here's our one antenna. This was probably an antenna that you string out, an external antenna. It says open link when using external antenna. So it's got an internal and an external. Someone had this just shoved in the back here. We'll remove that. Get that out of the way for now. Okay, let's take a look at what we got in this one to change. Well, we got lots of asbestos, that's for sure. And the last thing I want to do is disturb this stuff. Don't want to breathe in the dust from it, that's for sure. I got 1, 2, 3, 4, 5, 6 capacitors for sure that have to be changed, these paper ones. 0.5. Looks like that's another point. A 0.05, a 0.05, a 0.05. I probably have some 0.047s. Looks like this one's had the power cord replaced at one point. Someone just stuck it on with tape. It's always a sign that someone knew what the hell they were doing. Just tape it up. That's an input for external input cap. Okay, so 0.05. So let's see if I've got some 0.047 is probably what I'll have to go to. That'll be the closest I've got. Let's just see what I've got as far as caps. In addition to the ugly paper caps, this one's got some black beauties in it too. This one's got a crack in it. I've got some 0.47s. I changed these ones out right now. I don't know that I've got the other values, but we'll swap these ones out just to get going, and then I'll pick some more caps up next week, and we'll see what we can do. But I'll do these 3 right now. Start on the restoration on this one. Looks like there's a clip that went around the back of this that's missing. We can replace that with a piece of wire just to stop this from pulling out. You see, there's a E-clip on the back there that obviously has been lost, but I think if I can just stick a piece of wire, solid wire around there just to hold that together so it doesn't fall apart. So something like this, just take a piece of wire, put it into the groove and twist it around. Maybe even solder it down so that it can't come undone. But twisting it'll do for now. That'll prevent this from pulling through, you see. That'll stop that from pulling out. There, that'll work. Okay, that part's fixed. Let's start with these paper caps down here. We'll just cut them out, replace them. It's amazing how much smaller they are compared to these old relics. And you guys are probably wondering why I've gone back to my old soldering iron. This one, well, because this one here just works. It's a bigger tip, so you get more heat right to the tip itself. Those other irons are nice, but they have such a small tip on them that it just takes forever to get heat transferred. So come back to using this one, at least for these type of repairs. Gonna If it looks like I'm not really worried about the orientation, I'm not. You'll get some of the guys who will talk about the outside foil and how it's important that you match the outside foil to the outside foil. And it can, we've talked about this before, it can make a difference on larger physical capacitors, but when you're talking caps this small, it's really not going to make much of a difference. Some probably might argue that, but in reality, you might be able to measure it, slight impedance different, but in reality, you're not going to hear it. It was more of a problem when you had large physical capacitors such as those, just because the surface area was much larger. When you're dealing with these small ones, it's really not as big an issue as it was on the larger ones. So I'm not too worried about it. Plus the fact that this receiver is more of a showpiece. I just want it to work. It's not something that's going to be, listened to every day as a regular receiver to listen to. And I wouldn't do that with any of these old tube relics. They are more for show. And it's nice to have them working so that you can show them off and show that they work, but it's not a daily driver. And I would never use an old antique radio like this as a daily driver, even though some people might want to use their old radio as a daily driver. I would never do it, just because of the fact that you've got old obsolete tubes. They've only got so many hours in them. So why run them up excessive hours? It's fine, turn it on, play it for a few minutes, show it off. Here it works, listen to what we can pick up on it. But as far as using it to listen to on a regular basis, I'll use something a little more modern. These are, nice to have working, but I wouldn't want to be using them constantly. Plus the fact that they're all a fire hazard. Get the other 0.47 in here. And then I'll go through and see what other caps I have the values of, and we'll change them out. And then the rest of this, well, we'll have to order them in. But I'll show you what progress I'm making in this video, because there'll probably be a second part to this as well as when I do the other one. But for now, we'll just see if we can get this thing to kind of produce some sound, produce some thumbs down for not finishing it. You could probably let these two slide for now. I've done this Black Beauty that was up here that had a crack in it. I've replaced that one, this one here. I can probably let these ones slide for now, because this is just the like a phono input, which we're not going to be connecting it to anything at this point. And this one here is on a switch, which is, I think, probably tone control. Switch, it's either on or off. I don't know what that switch is for. But when the switch is in the off position, which it looks like it is in the off position, this is not connected. So we can probably get away without changing that one right at the moment, just for testing purposes, until I can get some inventory. I got one over here that definitely will need to be changed. What is this value on this one over here? This is a 0.01, and I should have a 0.01. Let's see what I've got here. 0.022, gotta have a 0.01. 0.01 right here. I've got a 0.01. So let's change this one out. And there's another one over here, that wax molded paper cap that I'll be changing out. And then maybe at that point I can try this thing and see if I can get any sound out of it. And then we'll get the rest of the caps and change them out when I get into the shop to pick some up. But we'll do this one because this is obviously a critical cap, this one. This last one I need a .0047. And that might be a stretch. Let's see what I can find. So this one, besides being in where all the asbestos is, it's going to the volume control. So this is a coupling cap that's coupling the audio in to the audio amplifier. There's a big wire sticking off there from, look at this. There's a big wire sticking out of here from before. Like someone changed it before and just wrapped it around and just left a big chunk of wire. They didn't trim the wire off. What an idiot. Okay, well, we'll just do the same. We'll just leave a big piece of wire on there too. Oops. Didn't get it cooled down enough. At this point, I probably can power this radio up without having it go up. Okay, I got it plugged into the dim bulb. Drawing a little bit of current. I can see the dim bulb glowing dimly. I got noise. Main filter shot for sure. See, first of all, the light bulb for the dial is not where it's supposed to be. It's supposed to be up here. Burned out, but it should be sitting up there. So our main filter for sure is open. But the fact that we're getting a hum out of this unit is indicating that, well, things are working. The power amplifier tube has appeared to be working, but we're just getting a lot of AC hum because we have an open filter. So I'm going to leave this where we sit right now, because at least I know at this stage of the game that we're going to get somewhere. If I put my meter on here, we can just watch our DC voltage. Well, we won't. We'll probably have a lot of AC in here, but 246 volts. Yeah, that one's probably open. 177. But we know that the power transformer works. We know that the audio output tube is obviously working. Speaker's working. We got a lot of hum in there because we've got open filter cap in here that's gone open. That's going to be this big. It's a 3-part cap. I'm going to get some parts. I'm going to go down to the parts store on Tuesday, and I'm going to get the rest of the parts, and then we'll see if we can get this one working, and then we'll work on the other one. I got to find a 50C5 tube for the other one that we looked at earlier in the video, but I'm going to leave this now, leave you guys in suspense, and we will finish this up once I get the rest of the parts for it, including the main filter cap and these other parts. We'll get some more parts in here. We'll get them all swapped out and then see if this thing performs. Thanks for watching. We'll catch you in part 2 for the restoration. Bye for now.